Question 11. Got no idea what's happening with this question, but I do know it's geometric. So I would start off by writing down A, then AR, and then AR squared, and so on. So term 1, term 2, term 3, term 4. Okay, so the common ratio is R, yeah, like usual, and then U1 plus U3. U1 plus U3 equals 6. Okay, so U2 plus U3, so that's AR plus AR squared equals 6. So what else do we know? We know term 4 equals 8. So that means AR cubed equals 8. And we just want to get rid of A, don't we? Because look, this has got no A's in it. So if we rearrange the thing we just wrote down there, so if we get A on its own, A is A over R cubed. And then we just want to lob that up here into the first one. So that will give us 8 over R cubed times R plus same thing times R squared equals 6. And simplifying that, what's that going to give us? 8 over R squared plus 8 over R equals 6. Let's times everything by R squared. Oh, what happened there? Come back. There we go. So R times everything by R squared. And we've got 8 plus 8R equals 6R squared. Let's divide everything by 2. Divide by 2, we get 4 plus 4R equals 3R squared. And hopefully that's what we're trying to prove, something like that. So get everything on the right hand side. And we've got that, which is what we're trying to prove in part A. Then in part B, what does it say? It's just got a sum to infinity. So if it's got a sum to infinity, that means that only so geometric sequences only have a sum to infinity if the modulus of R is less than 1. Otherwise the terms will stay the same, or they will diverge. So in order for the terms to converge, you need R to be 0 point something between -1 and +1. So we need to work out what R is. So if we solve this quadratic, just solve that on your calculator, you'll get R equals 2, or R equals -2/3. As we said here, we need R to be between -1 and +1. So that means we can't have that, and R must be -2/3. So if R is -2/3, we can now just use our sum to infinity formula. Sum to infinity is A over 1 minus R, and we're just going to put that in there. Oh, sorry, I'm getting this wrong. We don't actually want to find the sum to infinity. Yeah, scrap that. We only want to find term 1, and that is A. So can we find out what A is? Well, if we go back up here, we know from this that A is just 8 over R cubed. So if we just do 8 over R cubed, so actually that is supposed to go in here. So we've got 8 over -2/3 cubed, and if you type that into your calculator, you get -27. So part C, oh, we do want to do the sum to infinity now. So we've already done all the hard work. Sum to infinity is a over 1 minus r, which is minus 27 over 1 minus 2 thirds. Type that in your calculator and you get minus 81 over 5. Finished.